Hello, and welcome to a video on Exponents Part 2, brought to you by the Answer series. In this video, we will be looking at exponential equations. I've got 3 examples here for you. I want you to pause the video, I want you to try these, and then we'll look at them together. In the first example, I've got x to the 1/3 equals 2. Now I want to solve for x. So to get x, that means I need x to the power 1. So what do I do to get from x to the 3rd to x to the 1? Well, I raise it to the power 3, because remember we multiply these exponents. A third times 3 is 1, and x to the 1 is just x. What I do on one side of the equation, I have to do on the other side. So I get that x is equal to 8. In exactly the same way in 1.2, I've got x to the power 3 over 2. How do I get that to be x to the 1? I raise it to the power 2/3, because 3 over 2 times 2 over 3 is 1. And what I do to one side, I must do to the other side. What else I've done is I've written 8 as 2 cubed. That gives me x to the 1, in other words x. Multiply your powers together and you get 2 squared. In other words, x is equal to 4. I do exactly the same thing. I want that to be x to the 1, so I raise both sides to the power 3 over 2, because 2 over 3 times 3 over 2 is 1. 25 I write as 5 squared. Multiply your powers and you get 5 cubed. In other words, 125. And then there's a very interesting thing here. Because this involves an x to the power 2 over 3, that means the cube root of x squared. And because it's a squared, my answer has plus or minus. Because if you square positive, you get a positive. If you square negative, you get a positive. So when the top of the fraction is an even number, your answer is going to be plus or minus. I've got 6 examples for you here. I want you to pause the video. I want you to try all 6 of them, and then we'll look at them together. In 2.1, the first thing I do is I write 9 as 3 squared and 27 as 3 cubed. Powers next to each other, I multiply. I then have an equation with base 3 on each side, which means that the exponents must be equal, and I solve the equation and get my answer for x. In 2.2, be very careful. This is 3 to the 1 times 2 to the x. I have different bases, different powers. I cannot multiply them at all. I cannot simplify this at all. So the first thing I need to do is take the 3 across and divide. 96 divided by 3 is 32. And then 2 to the power what gives you 32? It's 2 to the power 5. 5 to the x plus 1 can be written as 5 to the x times 5 to the 1. There are 2 terms, so I take out a common factor of 5 to the x. I'm left with 5 to the 1 minus 1. 5 minus 1 is 4. I take it to the other side and I divide. And then 5 to the power what is 25? It's 5 squared, so x is equal to 2. In question number 2.4, that is a trinomial. If you are happy factorizing it, perfect. If not, what we're going to do is the following. 2 to the 2x I can write as 2 to the x squared. And what I'm going to do is I'm going to let 2 to the x be equal to a. So there's a 2 to the x, there's a 2 to the x. So in place of them both, I put a. There's a much simpler trinomial to factorize, which I do. And then what I do is I then replace the a's back with the 2 to the x's. 2 brackets multiply to give you 0, so one of them must be 0. So either 2 to the x equals 4, or 2 to the x is equal to minus 3. But if I think of 2 to the x, the graph of y equals 2 to the x looks like the following. It's an exponential. Can 2 to the x ever equal minus 3? No, it can't. So I need to reject that answer. So the only answer I can have is 2 to the x equals 4. In other words, x is 2. In 2.5, 3 to the 2 minus x can be written as 3 to the 2 times 3 to the minus x. 3 to the minus x is 1 over 3 to the x. And then what I do is I multiply by my common denominator. So that becomes 3 to the 2x. This term becomes 3 squared, in other words 9, and this becomes 10 times 3 to the x. Take this term across and set up your trinomial. Again, this is 3 to the x squared. So what I can do is I can let 3 to the x equal a. So in place of 3 to the x, go a's. Factorize, and then replace the a's back with 3 to the x. So either 3 to the x is equal to 9, in which case x is 2, because 3 squared is 9. Or 3 to the x is equal to 1, in which case x is 0. In these two examples, if you can go from the original and factorize straight as the trinomial, that's brilliant. And from here, straight into that one. If not, let something be a and then work with it that way. 2.6 is a lovely example. So you've got something to the power something equals 1. Now you need to think, how can you get 1 as an answer? Well, you know that 1 to the n is equal to 1. So 1 to any power is 1. So this part could be equal to 1. Because 1 to any power is 1, so x squared minus 3x minus 3 could be equal to 1. But you also know that anything to the naught is 1, except for 0 to the 0. So what you can do is you can say the exponent could also be naught, because anything to the naught is 1. And once you've got that, it's then simple to get your answer. So set up the quadratic, which you factorize, and you get your two answers. This one, factorize, and you get your two answers. So a lovely example, really, really nice example. The last one I want to do is a simultaneous equation involving exponents. So pause the video, try this one, and then we'll look at it together. Okay, this one's a long one. I take this equation. I break 9 up into 3 squared, and I multiply the exponents. 27 is 3 cubed, and I multiply the exponents. I'm multiplying. Same basis, so you add your exponents. I now have 3 to some power equals 3 to some other power, which means the exponents must be equal. Because I'm solving a simultaneous equation, I either want to make x the subject of the formula or y the subject of the formula. In this case, I've made x the subject of the formula, and I've divided throughout by 3. Now, you know that this x and these x's are the same, because I'm solving simultaneously. So in place of these x's, I'm going to put minus y minus 2. I then multiply the brackets, and I set up my quadratic, which I factorize and solve. And just remember, your quadratic is in y, which means you are solving for y. So just be careful you haven't made those x's. I then substitute these two values back into this equation, and I get my corresponding values for x. So my pairs of numbers are 1, minus 3, and minus 3, 1. So there are my pairs of answers. And it's quite fun just to have a look at the graphs. So there's one graph, and there's the y equals minus x minus 2. How many times do they cut each other? Twice. There are the 2 points of intersection that I got.
Check out the video description below for practice questions from our study guides. If you found this video useful, give it a like and subscribe to our channel so you don't miss any new episodes. Follow us on Instagram or Facebook to stay on top of the latest TAS news and launches. So that's it for now from the Answer Series, your key to exam success.